Now we solve the inequality you see here. The least common denominator is 30 because 2, 3, and 5 are all relatively prime. None of them has any factors that are equal to the factors of any of the others. In fact, all three of them are prime and they're all different. So we can safely multiply those three numbers and we get, again, 30. That's going to be our least common denominator. When dealing with an equality or an inequality that has denominators, it's usually the best practice to go ahead and multiply the whole thing by the least common denominator, because every denominator is going to divide that factor that you're multiplying by and give you whole numbers, clearing out all the denominators. Okay, so 30 times, okay, if we multiply both sides by 30, we're going to multiply 30 times this whole side, which means we're going to distribute the 30 through the subtraction of 5 halves minus 3 halves. So we're going to have 30 times 5 halves minus 30 times x over 3. I said 3 halves, x over 3. Okay? 30 times this minus 30 times this. Less than or equal to 30 times your 7/5. Conveniently then, 2 goes into 30 15 times. 15 times 5 is 75. 3 goes into 30 10 times. 10 times x is 10x. And of course we have the minus. 5 goes into 36 times. 6 times 7 is 42. We get the simple inequality. 75 minus 10x less than or equal to 42. We don't have to deal with fractions anymore, at least till the very end when we divide both sides and end up with a fractional result. Okay, well then the solution is very straightforward. We subtract 75 from both sides, giving us negative 10x less than or equal to negative 33. Then we divide both sides by negative 10. Being careful to reverse the signs, because when you divide or multiply by a negative, you have to reverse the signs. Simple reason for that, but just remember this rule without having to actually go back to the reason. Usually I tell you to go back to the reason, but this one is so simple and so universal, just remember it. And then, if you get a chance, think about why it ought to be true. In any case, we get this. And then do the division. We get x on this side, 33/10 on this side. Very straightforward problem, especially once we multiply through by the least common denominator. Okay, now we have a quadratic equation here, x squared plus 2x plus 5. This was a quiz problem, and a lot of people wanted to say, well, there's no real solution. Well, we just did a section, excuse me, a section on solving equations in the complex field, solving equations, quadratic equations over complex numbers. So we apply the quadratic formula and we take what we get. When we're dealing with the complex number field, when we're solving problems over the complex numbers, we always get a solution. So x is going to be negative b. Well, I'm not going to read the quadratic formula to you. B is negative 2. B is 2, so negative b is negative 2. B squared is 2 squared, which is going to be 4. And 4ac is 4 times 1 times 5. So if we do 2 squared minus 4 times 1 times 5, that's 4 minus 20, that's negative 16. And the 2a is just 2 times 1 because the coefficient of x squared is 1. So we get negative 2 plus or minus the square root of negative 16 divided by 2. The square root of negative 16, we can factor negative 16 into 16 and negative 1. So the square root of negative 16 is the square root of 16 times the square root of negative 1. The square root of negative 1 is I, our imaginary number. And now our solution is negative 2 plus or minus, well, square root of 16 is 4, so we get 4. Square root of negative 1 is I, we get I. Divided by 2. Now dividing through by the 2, distributing the division by 2 or the multiplication by 1/2 over the plus and minus, we get negative 1 plus or minus 2I. Just to make sure, we check this solution. Okay? And I'm just going to check it for the plus case. You can check it for the minus case. We're going to plug negative 1 plus 2i into the original expression. Now I'm going to first, let's work out x squared. It's going to be negative 1 plus 2i quantity squared. Now, you should be able to do this using the distributive law, squaring negative 1 plus 2i. And you should also be able to do it using the special product for the square of a binomial. Either way, and you should do it both ways, you're going to get 1 minus 4i plus the quantity 2i squared, which comes out 1 minus 4i minus 4, 2i quantity squared being 4 times I squared being negative 1, since I is the square root of negative 1. So we get a negative 4 out of the square of 2i, and then we do the 1 minus 4, we get minus 3 minus the 4i. Okay, 2x is just going to be 2 times the quantity negative 1 plus 2i, which is negative 2 plus 4i. So now x squared plus 2x plus 5 is going to be what? X squared is negative 3 minus 4i. 2x is negative 2 plus 4i. Negative 2 plus 4i. And then we have our plus 5. Doesn't take a lot to see that this is 0. We have minus 4i here. We have a plus 4i here. The 4i and the negative 4i add up to 0. The negative 3 and negative 2 add up to 5. We add 5. We get 0. So everything goes away, and our result is 0, as it should be. And this verifies that the negative 1 plus 2i is the solution. The negative 1 minus 2i, you can think about it. If we replace this plus by minus, this minus will become a plus, and this plus will become a minus. So this plus will become a minus, and we'll get exactly what we have here, except we'll have a plus 4i here, a minus 4i here, and they still give us 0, as do the negative 3, negative 2, and 5.